Hello students, in this video I would like to explain calibration of ammeter and voltmeter. What is calibration? Why we need to do the calibration? Calibration is verifying the result which we have derived from the particular instrument with the standard one. That is nothing but calibration. Why should we do this? So that we can verify and we can confirm the readings or the data which we are getting from the instrument is correct and accurate one. Before doing the calibration of voltmeter and ammeter experiment, I would like to standardize the potentiometer. For standardizing the potentiometer, I am going to use this circuit and I am going to find the balancing length. Here A and B point is there in the potentiometer board, and I am going to use 2-volt battery. So this is actually the potentiometer board. Here we have A knob. This is B point, and to do the standardization of potentiometer, I need a battery eliminator with 2-volt and a Daniel cell which will give 1.1 volt, and I am going to use this rheostat with the ohms of 35 ohm and a high resistance and a galvanometer. Using these apparatus, now I would like to explain how can we find the balancing length of the potentiometer. So as per the circuit, I am going to connect the positive terminal of the battery with the point A, and the negative terminal is connected with the rheostat. The other point of the rheostat is connected to the point B, and from the A point I am going to connect the positive terminal of the Daniel cell, and the negative terminal of the Daniel cell is connected with the high resistance, and the other end of the high resistance terminal is connected with the negative port of the galvanometer, and the galvanometer, positive port of the galvanometer is connected with a jockey. So now I have completed the circuit, and I'll try to explain how can we measure the balancing length. So I'm going to give supply to this circuit. So just I'm switching on the battery eliminator as well as the Daniel cell. Now first we should verify whether the circuit which we have given is working properly. So for that, what I am going to do means I am going to touch this jockey with the first string, and I am going to touch this last string. At the time of touching this first string with the jockey, the galvanometer will show the deflection on one side, and at the time of touching this the last string, the galvanometer shows the deflection in the opposite side. Let's check. So now I am going to touch this string with the jockey. Yes. So it shows the deflection in the right hand side. Now I am going to touch the last string and the deflection is in the left hand side. So thereby we can confirm the circuit which we have given is working properly. In order to find the balancing length, what I am supposed to do means I should do. Okay, so I am going to touch the first string. Now the galvanometer shows the deflection extreme on the right side. So second string also extreme, third extreme, fourth extreme, fifth extreme, sixth extreme, seventh extreme, eighth. Okay, so 8 is not extreme. So what I am going to do means just I am placing my jockey somewhere else in the 8th string. Okay, so now see here, the galvanometer shows 0 deflection when I am placing the jockey on the 8th string at here. So now I am going to calculate the length by using this scale. So the A string is 100 centimeter, first string is 100 centimeter, and the second string 200, third one 300, 400, 500, 600, 700, and this is actually 700 and 706.5. So the balancing length is 706.5. In this way we can able to find the balancing length L0. So we have done the standardization of potentiometer, and we know the balancing length L0 value. Now I would like to do the calibration of ammeter, and for the calibration of ammeter, we are going to use this circuit. And what we have here is actually we have a 2 battery eliminator. It's 2 volt battery eliminator, and we have used rheostats, and we have 1 ohm resistance here, and a galvanometer. Of course, now we are going to do the calibration of this ammeter. Fine. So we also have high resistance and jockey. So with this apparatus, we are going to give the circuit, and we are going to do the calibration. So as usual, in the potentiometer we have 2 points. A, this point is nothing but B. So here from the first battery, the positive terminal is connected with the point A, and the negative terminal is connected with the rheostat. The other end of the rheostat is connected with the battery. And now here we have a second battery. The positive terminal of the second battery is connected with the resistance, and the positive terminal is connected with the terminal A. Here the other end of the resistance is connected with the positive of galvanometer, and the negative of galvanometer is connected with the resistance, and the other end of the high resistance is connected with jockey. And here we have the end of the resistance which is connected with the galvanometer. From that end I am going to take another wire, and which is connected with the ammeter, and the ammeter, the negative end of the ammeter is connected with the rheostat, and the other end of the rheostat is connected with the negative terminal of the battery. In this way we are closing this circuit, and now we are going to do the calibration. So let me give the power to this circuit. So just I'm switching on the battery. Now this is the rheostat, which is connected with the second end of second battery. So just to see this ammeter. So if I change the rheostat value, means you can see the changes there in the ammeter. Initially, I'm going to set up 0.5 ampere, 0.5 amp here. So I have connected. Let me check whether this circuit works in a proper manner or not. For that, what I'm going to do means I'm going to place this jockey on the first string and the last string. So you can see the opposite side deflection there in this galvanometer. So just I have placed the jockey on the first string. So the deflection occurs in the left hand side, and in the last string the deflection occurs there in the right hand side. So which means that the circuit is connected, all the components are connected in a proper manner. Now I can do the experiment, and what I'm going to do means I'm going to find the balancing length for this 0.5 amp. So where I can get the balancing length, let's check. So here I am getting left side deflection, and in the second string I am getting right side deflection, which means that the balancing length is between the first string and the second string. So just I am moving. So here at the end of the first string I got the balancing length, so the deflection is 0. So I am going to measure this balancing length. It is roughly approximately 91 centimeter. Fine. So now I'm going to note down this reading here in the given tabular column. So first I have given 0.5 amp in the set up the 0.5 amp there in the ammeter. For that, the balancing length which we got is 91 centimeter. Now by adjusting the rheostat, I'm going to allow 1 amp current through this circuit. For 1 amp, once again I am going to find the balancing length. So I am going to place the joystick on the first string, left hand side deflection, and the second string also left hand side. Third string I got right hand side deflection, which means the balancing length is between string 2 and string 3. So just I'm moving here. Now so here
ஒரு நிமிஷம் பஸ் இங்கே வைங்க இங்கே வச்சு இப்படியே போக தானே ஒரு நிமிஷம்
இது செகண்ட் ரிங்கோட ஸ்டார்டிங்கில் பஸ் இங்கே Okay, so here I got null deflection. Now my joystick is there on the second ring. So I have completed the first ring, which means 100 centimeter, and in the second it's roughly around 179 centimeter. So the balancing length for the 1 amp is 179 centimeter. So I am going to note down here, and this is L value. Actually we have already know the L0 value by doing the standardization of potentiometer experiment, and by using this formula one can able to find I dash value. I dash is equal to 1.08 divided by R into L0 into L. Here R is 1 ohm. So thereby one can able to verify whether the given ammeter is showing proper value, accurate value or not. Thank you.